In this video, we're just going to discuss Gibbs free energy, which was sorry about that. We're going to discuss Gibbs free energy, which was defined by Joshua Gibbs. It's delta G equals delta H minus T delta S, where of course T is temperature, H is enthalpy, S is entropy, which is a measure of disorder. Delta G increases with increasing delta H, which is bond energy, and it decreases with increasing entropy. As you notice, is a measure of disorder. Reaction is favorable or spontaneous if delta G is negative. Delta G is negative, it's spontaneous. It's unfavorable, non-spontaneous, if delta G is positive. And of course, if delta G equals 0, then the reaction is at equilibrium. Well, go through this one more time and then I'll give you some more information. Delta G is equal to delta H minus T delta S, where T is temperature, H is enthalpy, S is entropy, or measure of disorder. Delta G increases with increasing delta H, which is bond energy, and of course it decreases with increasing entropy. It's favorable or spontaneous when delta G is negative. Negative delta G is spontaneous. Unfavorable or non-spontaneous when delta G is positive. Delta G is equal when delta G is equal to 0, reaction is at equilibrium. Equilibrium is defined as the point where the reaction rate in one direction is equal to the rate of reaction in the other direction. At equilibrium, there's a constant product in reactant turnover. The term spontaneous is used to describe a reaction system where delta G is, of course, less than 0. This can be misleading, as you may realize. You think spontaneous, happens immediately, rapid rate. That's what most people think of when they think of the term spontaneous. That's not necessarily true. It's spontaneous in the context of chemical reactions. That's not necessarily true. For example, many reactions have a negative delta G, indicating that they are spontaneous from a thermodynamic point of view, but they do not necessarily occur at a significant rate. Spontaneous means that a reaction may proceed without additional energy input, but it says nothing about the rate of reaction. That's why sometimes you use enzymes. Thermodynamics will tell you where a system starts and finishes with nothing but the path traveled to get there. The difference in free energy in a reaction is only a function of the nature of the reactants and products. Thus, delta G does not depend on the pathway a reaction takes or the rate of reaction. It's only a measurement of the difference in free energy between reactants and products. Now, you may wonder, like for example, many of the reactions that occur in your body, assuming that some of you may be biologists, most of them, they do not have the, negative delta G, favorable. Some of them have positive delta G. So how do the reactions in your body happen? It's something, it's called reaction coupling. Basically, one of these unfavorable positive, some of the reactions in your body have the positive delta G, unfavorable. They won't occur on their own. What happens is you have reaction coupling. A reaction that's very spontaneous, very favorable, high, negative delta G. It's coupled with one of these reactions, allowing the reaction to occur. That's basically what happens in your body. And of course, we can discuss a little bit about regulation of enzyme activity. I'll go ahead and just add this. Metabolic pathways in the cell are not all continually on, but must be tightly regulated to maintain health. For example, if glycogen synthesis and breakdown occur in the same cell at the same time, a great deal of energy will be wasted without accomplishing anything. Therefore, the activity of the key enzymes in metabolic pathways is usually regulated in one or more of the following ways: covalent modification, proteolytic cleavage, association with other polypeptides, and allosteric reaction regulation. Now, this is a lot. I mean, if you take, if you're going to study for the MCAT, you need to know this, and then you have to, biochemistry. When you take biochemistry, those of you that will take biochemistry, you will definitely need to know this stuff, but make sure you study this free energy, reaction rates, rate of reactions, because that stuff's going to help you in biochemistry. And you can expect that stuff on the MCAT. Again, delta G is equal to delta H minus T delta S, where T is temperature, H is enthalpy, S is entropy, the measure of disorder. Delta G increases with increasing delta H bond energy and decreases with increasing entropy. Favorable non-spontaneous is negative delta G. Unfavorable non-spontaneous is delta G is positive. Delta G is equal to 0. Reaction is at equilibrium. As I was saying earlier, though, just because it says that a reaction is favorable or has a negative delta G does not mean it's going to happen like that in a heartbeat, quick. That's why you got to use enzymes. Enzymes just speed up the reaction, and the enzymes they're basically proteins that speed up a reaction, but they are not consumed in the reaction. Delta H is equal to delta G is equal to delta H minus T delta S. This is actually quite easy to learn. If I can learn this stuff, you guys can learn this stuff, trust me. T equals temperature, H is equal to enthalpy, S is equal to entropy, measure of disorder. Delta G increases with increasing delta H bond energy and decreases with increasing entropy. Favorable, spontaneous, is delta G is negative. Unfavorable, non-spontaneous, delta G is positive. Delta G is equal to 0. Reaction is at equilibrium. Of course, the second law of thermodynamics I didn't mention earlier. Second law of thermodynamics states that disorder tends to increase. Consider then the mathematical definition of delta G above, which means reaction will be favorable, one with a decrease in free energy, delta G is less than 0, or one with the increase of free energy. Favorable reactions have delta G is less than 0. We can deduce this from the second law equation, because the second law states that increasing entropy is favorable, and the equation has delta G directly related to negative T delta S. You see that negative T delta S right here. How does the delta G for a reaction burning oxidizing sugar in a furnace compared to delta G when sugar is broken down, oxidized in a human? The delta G is the same in both cases. Remember, as we were saying earlier, delta G does not depend on the pathway, only on the different energies of the reactants and products. I'm just going to go let you see this again. Without me talking. feel free to watch any of my other videos. Feel free to subscribe or like or however you want to do. Thanks.